So after that, we will deploy this type of configuration. Like suppose if our DNS will be app1.hypercloud.in, then it will be our one demo app. And suppose if our DNS sub DNS will be different, like for example WordPress or app2.hypercloud.in, then it will redirect us to our standalone WordPress site. And suppose if it will be grafana.hypercloud, then it will be grafana dashboard. And suppose it will be kiali, then it will redirect us to kiali, and so on. After that, we will install Jenkins server and try to create our CICD pipeline for our applications, like our EKS demo app and WordPress site. And after that, in top of our application server, we will configure web and its log analysis, and also we will configure VPC flow log. And after that, we will configure Route 53 records, so our users are able to access our application using some particular DNS. Any doubts on this agenda?
No, we are good.
Okay. So let's so currently what I did here, so I launch one EC2 machine, and it will be like our all T2.micro, because we will not do anything on it. This will be only for our base machine. Like it will interact with our EKS master. So this will be our machine, and its host IP address will be this one. And on that, this is my that machine. So you can see this IP, and I connected this using VS Code. So it will be easier to write any code. So this will be our configuration file for, but before this, you need to install kubectl. And this will be your kubectl command line tool. Also, you need to configure AWS and also EKS CTL. So by using this, you can able to install Kubernetes cluster. So this is our Kubernetes config file. So this will be our API version. And if you work with Kubernetes deployment, then you know these three specs will be main: API version, kind, metadata, and its specification. So here, this will be our cluster name, and our region will be US, Ohio region, and this will be our VPC. So currently I am taking default VPC, and its subnet is like this. We have one subnet, two subnet, three subnet, and this will be our node group name, and this will be our T3A medium size instance type. So just you need to create EKS create cluster -f. What is the name of this? EKS config.yaml, and just press enter. It will take little time to create this. Meanwhile, let's go to our slide. Yeah. So this will be our Kubernetes architecture. So in core, it mainly consists with two components. One will be master and other will be worker. So what are the difference between master and worker? Like suppose master is like Kubernetes heart. It will control all the worker nodes. Like suppose if in this diagram, you can see, like suppose if you have any any pods or any services or any deployments. So what it will do, it based on kube controller, it will check its replica count. Like suppose if you want 3 controller, or if you want 4 controllers, so based on this master controller, it will able to give this configuration. And in master node, you will have one etcd. So etcd is like a key value store, and in this etcd cluster you will have all Kubernetes configuration, like all the configuration file for your deployment secrets, and this CRDs also. And in Cube AP, oh wait, huh. And in API server, like you can see here, API server is the only thing that interact with Kubernetes each component. Like API server will be interacting with the etcd cluster, it will interact with kube scheduler and controller. Also it will interact with our worker node. And this will kube controller will be responsible for controlling all the jobs, and scheduler will be responsible for schedule your Kubernetes pods. Like based on node affinity and the labels, you can specify your pods. Like this pods, like suppose in Kubernetes deployment, what you can do, like suppose you will have 2-3 types of application. One application will be for Java, and suppose it will take some memory, and suppose you have other type of deployment that will run on Node.js. So suppose that requires some RAM. So based on scheduler, you can specify your pods. Like this our Java machine will be go to our CPU optimized instance, and our Node.js will be go to our RAM optimized instance. And worker nodes, in worker nodes you will have kubelet. So kubelet is like a pilot. Like suppose if master wants to do any deployment, so it will not directly go to worker nodes and it will do. It will just using this API server, it will interact with kubelet, and in worker node kubelet will install pods based on Docker engine. And let me draw something. So message. Oh, I am not able to record. I am recording this thing. So after this session, I will send you this Zoom link. And can you give me permission? Thoda slow. Okay. News here. So suppose this is our master node, and suppose this is our worker node. And as I said, in here you will have, let's draw this with a different color, API server. So now at this time you will have like little bit clarification, like what is kube scheduler, what is API server, what is etcd, and what is kube controller. Any doubt on this? You can ask.
Can you explain once more the etcd?
Okay, sure. So this etcd, what it will do, like suppose you can think as a database. So suppose if you have a large Kubernetes cluster, on that you will have suppose lots of deployment files, deployments file, and their pods, secret, replicas, controller, and jobs, cron jobs, and so many things. So what it will do, it will store your all type of configuration file. Like suppose uh, mm, it will like key values, like suppose it will like Kubernetes storage, like database. So on that you can store your all configuration. So suppose if anything happens, so if you have your etcd cluster backup, so based on that you can get your cluster. If it like suppose if you lost your etcd, on that time it will be like very trouble. So what this EKS will do, EKS will, like suppose this is your Kubernetes master control, and suppose if your as of this you can see our master is very important. If if this master went wrong, on that case our worker will not work, right? So EKS, what it will do, it will create this master node in multiple AZ. Like suppose if you mention 3 availability zone, so it will launch this master into in uh, all 3 availability zone. And this etcd cluster also, it will be on multi-AZ. So on that time you will get high availability and disaster recovery. So suppose if your one node will down, other will take care of it. And suppose you have master node. So in manage Kubernetes cluster, what you can do, you can't directly log in into this master node. You can access this master using either kubectl dashboard or kubectl API. So what it will do, this suppose if you do any kubectl get pods or any kubectl command, so it will directly interact with your it will directly go to your API server. And based on this API server, like suppose if you want to fetch any data, so it will try to fetch with etcd cluster. And suppose in this worker node, let me draw something. You will have kubelet. So suppose if you want to deploy any pods into your Kubernetes cluster, so what you will do, you will do some kubectl create pods and some name like kubectl create nginx. So what it will do, it will go to your API server and it will check like this type of configuration is already there or not. If it is already there, then it will try to update that pods. So suppose first it will go to in etcd and it will check no, it is not there. So after that what it will do, based on your configuration, it will go to kubelet. And kubelet, what kubelet will do, based on some configuration, it will install these pods into these worker nodes. And here you will have some container. And also, and like suppose if you are running any pods, so pods like it is in Kubernetes, pods no Kubernetes object we will learn in next slide. So in this architecture you have any doubts? Okay. So in meanwhile, you can directly access master node with a kubectl API or dashboard, and based on these commands, you can this Kubernetes master will deploy your all Kubernetes objects like object, pods, deployment, replica set, and others into your worker nodes. So let's go to slide. So we covered master node, worker node, kubelet, API, runtime. Okay. So in this Kubernetes object, so you will have like pods, different daemon set, replica set, deployment, service, and service will be like cluster, IP, node port, load balancer, cron job, and namespaces. So pod is like, this is, you can see this is pod. So in pods, like in Docker environment, like it is very smallest part of object. Like in Docker, you can suppose one container. So here also in Kubernetes environment, pods will very smaller set. But in this pod, you can have multiple container. Like suppose this is your application and this is your database, and in this you can suppose like this will be your volume, this will be your application, and this will be your redis. So in pods we can only deploy tightly coupled container, so that will be like very useful to each other. And in daemon set, in this figure you can see daemon set will launch one pod in each worker node. Suppose you will have 6 running worker nodes. So and if you want to deploy any pods, and your requirement will be your pods will be running on each worker node, so you will use daemon set. And suppose replica set, like suppose you created one pod and you want this 2 3 replica. So based on this replica set, you can able to increase your pod number. And deployment is like it is a top level of replica set, but in this deployment you will get some extra benefit, like you will get some blue green deployment approach. So on that, what will happen, like suppose if you have 100 pods, so it will change your existing pod with 25%. Like suppose if you have 100, so first it will try to update 25 pods. If it will success, then it will go to other, otherwise it will roll back to previous version. So is it clear? And what happened, failed to create okay, wait. Okay, now here this will be our EKS. So in this, suppose this is our own VPC and this is AWS side VPC. So this Kubernetes control, it will like based on, suppose this is endpoint and we are getting through, we are accessing it using kubectl. So if we will hit this load balancer, it will try to interact with our Kubernetes control plane. And in control plane, then we will have multiple masters in each VPC, in each availability zone. And based on this, it will interact with our worker nodes. Let me check if our cluster is ready or not. It's taking a little bit time. So as this EKS cluster, for creating this EKS cluster, it is taking little bit time. So if you have any doubt, you can ask.
Hello.
Hello, yeah.
So in worker node, apart from this pod, what means what are the other components apart
In
from pods?
apart from pods, so like this pods and others is not like oh, wait. So suppose this is your worker nodes, right? And in this worker node, you see you will have one kubelet, kube proxy, and runtime container. So it is not like object; it is like core components. So it will be like very important to do other work. Like in master node, you will have API server that will manage all the jobs, right? So similar in worker nodes, you will have some components. So kubelet will be responsible for scheduling all the jobs in your worker nodes. So suppose as your question is pods. So this pods is like one smallest component object in Kubernetes cluster. So here you can see this is your pod, and in this you have only one container, right? So based on this, you can create pods, deployment set, replica set, and service. Service is also very important. Like suppose if you have any pods, right? And if you want to access this pod, so what you will do? You need to create one service in front of this pod. So, and suppose if you want to communicate internally, on that time you will have cluster IP as a service, and node port and load balancer will be for if you want to expose your traffic into public. On that case, you will use node port and load balancer. But in node port, you need to in Notepad, it will expose traffic within 30K and 32K. Between this range, it will expose any. It will expose any port, and this cron job also, like suppose as this name cron job, you can schedule this any task, so it will run on that time. So suppose if you want to take log backup or your cluster backup, so you can select this cron job as a object type kind, and it will do your work. Any doubt on this? Let me check if it is created. Still in creating. It is taking little bit time. And also by using this EKS, you can attach multiple security group. Like suppose this is your pod. and it will expose one IP address. So in this IP address, you can attach your security group. So this is new feature of EKS. And also in EKS, you will face little bit problem, like it is using its own CNI plugin. So but by using that EKS AWS VPC plugin, you will have IP problem, like it will take lots of IP. So if you are trying to use EKS on that time, your subnet range will be higher. Otherwise, you will get this IP limit problem. And other thing. Let's wait for 5 minutes. So on that case, our EKS cluster will be ready. So we can directly go to our demo.
Hello.
Hello.
Yeah, is it okay? I thought it jammed.
I need to play that. So it will take little bit time. So let's go to some configuration file. So suppose if you want to create any pods deployment, so what you will do, you just need to define any file name with a .yaml extension, and it is nothing but yet another markup language. So in this, what you have to do, yeah. So just you need to mention three things like API, version, this will be important, kind, metadata, and specs. So in API version, like you will have different type of version. Like suppose if you can see here our Kubernetes version will be 1.17, but before this 1.16 you will have some V1 or V1 extension, V2 slash extension. So this type of API version will be there. So currently we are using V1, and suppose if our kind will be pod, and here in metadata you need to define some name, like suppose name will be my pods, API version, kind, metadata, specs. Okay, and in here you can define multiple container like spec specs. Yeah, we are ready to like containers. Okay, and it will be your list. And so in YAML, if you want to give any list, just use this hyphen, and here you need to define your container specification. Like suppose if you want its pod name will be nginx, and you need to define its, wait here. And you need to define its image also. So image also will be your nginx, right? And nginx, then if you want to define its container port or any memories resources, so that you can do here. Like suppose resources, and in this limit requested will be like suppose 100 M. This will be your CPU request. This will be CPU 101, and memory will be like suppose if you want 100 MI. Yeah, now our cluster is ready. So you can check your cluster by using, is my screen is visible?
Yeah. If you could increase the font, please.
Okay, let me check. Increase font size. Now is it better?
Yes, thank you.
Yeah. So by if you want to check your service, your Kubernetes cluster, just add this command kubectl get svc. So suppose here you can see you have one Kubernetes, and its name will be, type will be cluster IP. And so in this, what you can do, like you have one Kubernetes running, and if you want to check your nodes, just add kubectl get nodes. So here you can see you have two nodes, and it's all in ready state. And if you want to get this IP also, add this flag. Yeah. So here you can see its OS and its kernel and Docker runtime, because Docker runtime is also important, as I showed you in architecture diagram. So now what we can now what we need to do, we have we have some application. So what will be the application? So suppose, let me draw clear this one. So we will have one front end, and front end will call some backend, and backend will be one backend is on Crystal, and same for this front end we will use Crystal backup and Node.js backend. So our front end will be able to interact with two backends. So for this I am referring some GitHub link. I will wait, let me show this to others. Where is this? Hello. Connection got lost. Hello, am I audible?
Yes, Ashish, you
Yeah.
are all audible.
So for this, I am referring this AWS-EKS front-end demo. So we will, this will be our application front-end, and in this we will have some Kubernetes file. So what it will do, suppose you have one deployment. So as name suggests, you will have some specification, and this is same as your this specification. This will be same as your pod selection, pod configuration. And if you want to use any other type of deployment, like suppose deployment or replica set, you need to put this within your deployments. So suppose here our replica will be one, and selector will be select based on its level, and we will define, it's defining some update. So it will be like 25% each. Suppose if you have 100 pods, so first it will update 25, and it will go to linear. And so this will be our configuration file. We are using this. So any doubts on this? Okay. So we have this front end, and front end consists of some files.
One question here.
Yeah.
The strategy, whatever you have mentioned, this percentages thing, is it part of green and blue deployments?
What? Sorry, I am not able to hear you.
Is it part of a green deployment strategy?
No,
25%.
no. Like suppose if you are not defining any strategy, so on that time it will suppose as a rolling update. So suppose if you have 100 pods, right, and if it is taking 25 this strategy, so what here you can see this type will be rolling update. So what it will do, like suppose in first time you have 100 pods running, right, and if it is taking 25%, so it will add 25 new pods, and it will check it's by using this liveness probe and healthy liveness probe, yeah, So based on this, it will check pod health. If it is okay, so what it will do, it will delete this 25 pods and it will go by linear, like 25, then 25, then 25, then 25. When this will be completed, our previous pod will be went down. Clear?
Yeah.
And here you have this, you can see this front end. For front end, I'm using service account, and the kind will be deployment and name and others. Replica will be to name selector type, and in metadata, you same label specification. It will take this image, and if you want to do any other image, just mention here. And here this will be pull policy, like you want to check this or not. If it is like here, you can define other thing also, and this will be your port. What we can say, you have a clear idea on services, like how services will work.
Yeah.
Okay.
And this labeling is it only for our reference, like when we search from GUI, or is there any particular reason why we mention labels?
Label, like you, like as I told you in pods versus replica set, like suppose here it needs 2 replica, right? So in Kubernetes world, you will have lots of pods running on Kubernetes. So how your deployment will understand, okay, I need to increase this pod with particular count. So based on this label, match label, it will grab all data. So suppose, see here, this is like your pod here. This metadata is like your pod, right? And suppose if this pod is running and here you need 2 replica. So how your Kubernetes will understand, like you, hello?
Where Q.
Oh, okay, I got it about replica. Thank
Okay.
Where QLN போட்டுருக்காங்க.
Sorry, I am not able to understand.
You don't have junction da. In the number and train number.
Can you mute please? SK.
Train வரும்போது அந்த நம்பர் போட்டுருக்கா. ஆமா, அவங்க முனையில போட்டுருப்பாங்க. அதான் ரெண்டாவது ப்ராப்ளம் தெரியும் அந்த.
Please try to mute yourself. If you want any, if you have any question, then just unmute yourself. Yeah. So this will be our front end, and for backend we have 2 apps. One is Crystal backend and another will be Node.js backup, right? So now what we can do, just we need to apply these changes. Like suppose if I go to apps, I don't want this gateway now. kubectl apply Node.js backend. Front end. And Crystal backend. So if you want to check its all thing, just use kubectl get all. Here you can see these deployments are it's want to create two replica, and here this is your desired, this is your like current specification. So currently it is 0, and for this currently it is 1, and it is currently 2. So this is same as like if you want to create deployment, it will internally call replica set. So based on this name, you can see these replica sets are there, and this tag will be based on your deployment ID. And here based on this, see, you have this number of pods. So currently it is on creating state, it is running, and it is running. So if you again do this thing, now you have all pods running, and see here you have services, 3 services, Crystal, Frontend, and Node.js, and all will be cluster IP. So as I told you in starting video, you have 3 different type of services: cluster IP, node port, and load balancer. cluster IP will be enough if you want to communicate internally in your cluster. But if you want to expose traffic to public, on that time you have to change this type. So what I am going to do, I am going to front end and I am changing this service type. So service type, or just do patch. Wait. kubectl patch svc service, then your service name, this will be your service front end. Then it will be load balancer. Now it is patched. Now if you do kubectl get services, you will see one load balancer, and this will be your endpoint. So what it is doing here, see, in architectural perspective, it is listening on port 80, and it is like internally it is redirecting all the request into this particular port. And as I told you, in node port you will have like port ranges, like it will be on 30k and 32k between, you will get some ports. So it is internally, it is exposing redirecting on this port. And like, wait, let me show you configuration so you will have better understanding on this. Yeah, so wait, yeah, no. So here you can see one load balancer will be there. Here, and in instance you can see these two are in service, and here also you can see this listener. It is listening on port 80, and it is redirecting all traffic into this port. So in this instance, this particular port, which one, this 3082824, it will be like listening for our request. So if I go to this DNS, so here our app is working. So you can see currently this is our front end, and now this will be our front end. What you are guys are doing? Yeah, this, if you want this endpoint, I can share you, so you can also see in your browser. So this will be your load balancer, and this particular, these two things, it is your front end. And as in code we mentioned, we want two replica, and each replica will be on different reason. So why this is not working? Because currently we took only two EC2 instance, two EC2 instance, and it is on AZB and AZC. So first time it will, this will be our front end, and these two will be back end. And based on this request, our route will be on different thing. Any question on this? chat link. Okay, to everyone. Check, I shared some link on chat, so you can use also this thing. And now our slide. Now we are going to deploy WordPress site. So in WordPress site also you need to define some deployment, some stateful set and some daemon set and other things. So let me share my screen. Yeah. So as now we have one app running, this EKS demo one, and now we are going to create our second app. New folder, WordPress. And in WordPress also you will have pvc.yaml. So any idea what is PVC? Anyone?
Is that a persistent volume you're saying?
Yeah, it is like persistent volume claim. Suppose if you are like, there will be two type of volume in this. It's keep changing. Why work that way? Awesome. Okay, I am not able to understand your question. It's keep changing. It's work that way. Yeah, because each time your request will be redirecting to each pods. So suppose if you will get kubectl get pods, see you have this type of this number of container. This will be your crystal backend, this is your front end backend, and this is your backend. So node.js backend. So each time this request will be on different pod based on your routing policy. This policy also you can set on your ingress controller, like how your routing will work. Like is it will be on some linear, or it will be some weighted routing. So in this also, like suppose if you want to do some persistent volume claim, so here you like for this MySQL site, we need to create this persistent volume claim for this MySQL PV, and this will be for our WordPress. And here also you can see access mode will be read write once, and there is very important difference between this read write once and read write many. Like suppose if I choose this to read write many, on that time it will give me some error, because like in suppose if you are accessing this by default, it will like suppose if you do some kubectl get storage classes, you will get you have only GP2, and GP2 will be backed on EBS. So in EBS, if you are familiar with this GP2 and AWS, you can say this EBS will be on AZ specific. You can't use AZ volume into BAZ volume. So if you are using read write many, so on that time you have to define your storage class will be EFS. So this will be some thing. And now go to WordPress. Well, now we need to use kubectl apply pvc.yaml. Yeah, now we have for checking this, just add kubectl get pvc or pvc. Here you can see it will be like status ready after some time. And now if our pvc will work, now we need to use this stateful set. MySQL and we need to create one this stateful set. Any idea what is difference between stateful set and deployment? Okay, it is pending. Wait. Now just we need to apply this thing. Kubectl apply. Now we created our WordPress service. We have MySQL. We have persistent volume claim. We have stateful set. Yeah, now all things are set. Kubectl get all. Here some errors are there. Let's see. Kubectl secret we didn't pass, that's why our pods are getting filled. Here you can see by using this command kubectl describe pods and it will be your pod name. So here you can see message successfully assigned these pods, then attach volume success. Now here it is getting error like secret mysql pass not found, that's why it is getting error. Now we need to apply this thing. And what is our namespace? Kubectl create secret generic MySQL pass. Now, if you want to check this secret, just apply kubectl get secret. Here we have one this secret MySQL pass. Now, if I do kubectl get all, here we have this MySQL pod running. Node.js is working. Where is our WordPress? Okay, this is also working. Now check on this. Yeah, you can, if you want, just check this site. I'm pasting this link into chat. Here you can see our WordPress site is up and running. Any site title, like suppose if we want like cloud. Admin password SSF 123. Here you can use this thing, like opening. Any doubt on this, Aditya Bhaiya? And now suppose if our WordPress site is working.
No, Ashish, there's no doubt.
Any doubt like how these things are working or any other thing in infra side? So let me give you one brief. Like suppose this is our stateful set and this is our deployment, right? Wait, you can't see this one. New share. Check this one. We have two type of object. Like suppose one is our deployment and one is our stateful set. But why we use stateful set for this particular WordPress? Any idea on this? So generally what happened if you are using any deployment file, right? On that case, what will happen if you want to use any persistent volume claim or any other thing? So it will share per node. Like suppose this pod will be on some node. So for one node will be responsible for one EBS volume. But if you use stateful set, so on that case, what will happen for each pod, you will have different a persistent volume. So by using that, your volume will be persistent and you will like there will be very less chances to lose your data. And now what we did till yet, we have one app one, we have a WordPress site. Now we are going to use istio. So let me go through you on istio site. So if you have any idea on istio, like what is istio and why we are using this? Okay, no problem. So first thing will be you need to install istio and it will come with some predefined custom rules. Like if you do this istio download, then you will get one repository. On that you will have lots of sample documents that are mentioned in istio website. So after that you need to just export this path. So by using this you are able to use istio-ctl command and just use istio-ctl install. And if you use demo profile, on that case you will get two ingress point. One will be for ingress and one will be for egress. Egress will be for if any requests are going outside of your cluster. So by using that egress gateway, it will use that egress. And if you want to inject any sidecar, just you need to use this. You need to label istio injection will be enabled on default namespaces. So it will check this thing and it will enable this. So now we are going to install istio dashboard. So currently I have istio installed or not. Istio we have istio cd bin. Yeah, we have running istio. Now what we can do, just use istio ctl install. It will check this will be installed default istio profile. You will have different type of profile, but for demo default will be enough. Now it will you installing this thing istio core. And one more thing, istio will install all the CRD's resource type. Like in slide you see we have a pod, we have deployment type, we have a stateful set and all, but CRDs are custom resource definition. So istio will use this custom resource definition for installing its own dependencies. So our ingress gateway is also installed, installation complete. So if we do kubectl get ns, we have one istio system namespace. So istio will use this istio system namespace for doing its all deployments. So if you do kubectl get all -n, then its name here. These are things like it installs some pods, ingress pod, and services like this one, and deployment type and other things. And also what you can do, we need to enable this sidecar injection. So here what we are doing, kubectl label namespace default istio injection will be enabled. So currently what we did, we label default namespace to be istio injection enabled. So currently it will not install any sidecar injection on our running pod. If pod will stop and it will start, on that case it will inject this sidecar into our pods. So like in slide also I told you, in pod we like no restriction, like we have only one container running. It will be like one, two or many containers. So with our application container, it will use one sidecar. So it will be responsible for proxying each deployment, each services. Now we have some grafana also. CD, let's check. CD sample add-ons. Yeah. Here we have grafana, we have jagger, we have kiali, we have prometheus. Just we need to install these things so we can also check this monitoring things. kubectl apply kiali prometheus and grafana. Any idea what is grafana, what is prometheus, what is kiali? Hello, Dhaniram.
Yeah, Prometheus is a monitoring tool for the Kubernetes native tool, and the grafana is the GUI for the Prometheus, if I'm right.
Yeah. And what about kiali?
No, sure, I'm not about that.
Okay, so like in istio, I told you it is like service mesh, and based on this, like you can see some graphs like how requests are coming into your cluster. So suppose if I do kubectl get svc grep kiali, it will be on this namespace. Yeah, so currently we have one cluster IP. Let can patch with this with now we have one load balancer endpoint. So suppose if I copy this and paste it on browser, I will see one dashboard. Wait, it took little bit time. CTL. See here also you can see this target is unknown. Any idea why this is unknown? Any blind thing? Dhaniram.
Target is, I'm not sure.
Anything? What comes in your
Like,
mind? Why it is unknown?
like we have not defined that port.
Port, no, it is like suppose here you can see some percentage are there,
Oh,
right?
sorry, it's percentage. Okay.
So why it is happening? So like suppose if you are defining this type of horizontal pod, it is for HPA, horizontal pod autoscaler. So based on some cube matrix, it will check your pods CPU or RAM consumption. So currently we didn't install Kubernetes. That's why it is unknown. If we install Kubernetes on that time, it will not give us this error. So suppose if I do this kubectl get deployment on this thing, kube system, because kube system will be responsible for doing all internal work. So here we have only core DNS. Now we need to just install one what is it, kube component. So we have one GitHub link, just install this one. So after doing this, this unknown will be went down, and you can use kubectl top command as well. Matrix is not available, it will come after some time. And let's check on this our service. So here we have one load balancer, and it is listening on this port and this port. So just copy this thing, and I am pasting this also on channel, so you can also see this. It is private. I send you some link on chat. Just check out this one. Here, after this, you will get this dashboard. And you click on graph. Here, select namespace. It will be default. Here, empty graph. Why? Because our sidecar is not yet installed on our each machine. That's why here we are getting this empty graph. So if I go and if I reinstall all the pods, so we are getting, we are able to get some images on this. So just go to which one, to kubectl get pods. So we have this type of this number of pods running. Just do kubectl delete kubectl delete pods hyphen all. What it will do, it will just delete all things. So now I have one question. So if I delete this all pod, so my server will went down, or this will create again? Aditya Bhaiya. आदित्य भैया अनम्यूट करो.
Yeah, just tell me.
So like what I did here, kubectl delete pods all. So based on this, what it will do, it deleted all these pods. Like here you can see ECS cluster demo, this one front end, Node.js, MySQL, stateful set, all thing it got deleted. So if I do again kubectl get pods, I am able to get these pods or not?
Yes, you can get.
Why?
Because it have a process where if we delete something, so it will again come up, because Kubernetes have that application kind of thing that which can replicate those things which is already deleted, and again it will auto scale those things.
Yeah, but my question is, like, suppose this is not like suppose if I define only some pod, and if I deleted some pod, so on that time it will not recreate that one. It is creating because of it is part of our deployment and replica set.
Okay.
Got it or not? Like suppose here you can see this is your what? This is your pod name, like a deployment name, and this will be your what is it replica ID, and this is your deployment ID, right? So if I do here kubectl get pods, see here we will get this deployment ID is same, but this will be different. This is replica ID. So if you define object as a deployment or replica set, on that time in cube master also you have one component cube controller, right? So that will monitor each object, and suppose if it monitors like this pod is not there, so what it will do, it will recreate this thing. Here you can see age is like just 2 minutes, and this thing here it was running from 34 minutes and so on. Got it? So let me say you this thing. So this diagram is now it's able to work, but here also it is doing some unusual thing. Istio enabled. This is disabled. Okay, in default namespaces we have this enabled. Workload like for front end, you can see here front end is going to this front end. Oh, it is. Here, if you see, you can see this graph like for unknown. This is our WordPress site. For this load balancer, we have one ingress, and based on this, we have three type of services. So this is our front end, and front end is going to this side, and front end is also connecting with this Crystal backend and Node.js backend. Here you can see graph like this much traffic are going here, and for WordPress, this much traffic are going there. WordPress site, WordPress stateful, then it is calling with this master WordPress MySQL, and this is pass through cluster. Like if any request want to vent out, it will use this one. Any idea? Any question on this? Now you can able to see all the graph like this much traffic are going, and also you can use some inbound and outbound weighted routing. So suppose if you want to do some weighted routing on which one is here. So just click on this. Here you can able to see some traffic, edit traffic logs. Where is it? Yes. And currently we didn't configure this one. And also if you want to fetch log grafana, so we can also do this. Wait, let me share you this thing. kubectl get s istio-ingress kiali Prometheus grafana. Now here you have one grafana dashboard as well. It will take little time. Now you can see grafana dashboard. We have istio dashboard. See, if we click on this service mesh, here we have some requests like this much. 400 is not, we have this much request. What for this workload, it is like it for this demo we have 100 success rate, and for this currently it is not taking anything. That's why here you are seeing and for this also you can see traffic request. And there are also things that you can see here, like in istio you will have this mesh mixer performance service dashboard also. So in service dashboard you can see currently it is not coming through istio-ingress. That's why you are not able to see. Otherwise here also it will give us lots of data. Like suppose if we use our front end, this will be our front end. Here you can see this P50 latency, P90, P99 latency, and so on. And also if you want to install anything, just click on this import, and in new version of this Kubernetes, you can just use this ID. Like suppose if I do 315, it will have some Kubernetes cluster monitoring via Prometheus. just import. Oh, I need to select this. Prometheus, just import. It will add lots of data. See, cluster memory, and now you don't need to create each things. This is cluster memory, cluster CPU, file server uses. Currently we don't have any file server, that's why it is showing nothing. This is pod memory. You can see lots of things by using, just you need to import this thing. Save dashboard. And if you want to explore anything, just search Grafana dashboard ID. Here you can see lots of dashboard will be there. Like suppose if you want to find for Kubernetes, here you can monitor stateful deployments. Just click on this and you need to, this is its ID, copy this thing and import in our cluster. We have to general and istio, Prometheus import. Deployment CPU and all. Here you can see this graph, CPU uses, memory uses, and so on. Any doubt on this? See, here we can see lots of requests. For TCP, there are no traffic, but for HTTP, we have lots of traffic. See how traffic flows are there. From unknown, it is coming to, this is unknown means your load balancer. From load balancer, it is coming to this point, and from this point, it is coming to this, and you can see this traffic flow. And if you want to do any changes, you can check on this graph. Here it will be some weighted. So inbound. Okay, I need to log in with admin, then I am able to do this work. So till now, you have any doubts? Aditya Bhaiya.
No issues.
Also, you can see this thing, what success rate on istio diagram. So istio will be very useful if you are running production. And now istio, now what we need to do now? We installed Grafana. Now we need to use this thing, what you can see. We need to configure our ingress. So let's go to our code here. So suppose now for accessing this kubectl get svc, we have lots of load balancer, but this is not good. Now what we are going to do, we are using istio-ingress. So based on that ingress controller, it will redirect our traffic. So first thing will be, let's here we have gateway.yaml. Just open this one. Gateway.yaml. What it is doing here, API version will be networking istio because it is istio CRD. Gateway, it will be, name will be EKS gateway, and we are creating this gateway. Now in front of this host, what we need to do, EKS dot hypercloud dot in, and in virtual service this will be our demo app. Host will be this one, and it will come to our this demo app. So let's check this kubectl get svc. So our name for this is front end, right? Just copy and paste it here, and it is also listening on port 80. So now it will redirect all the traffic. If any users do this one eks.hypercloud.in, then it will redirect to our our application. So now just copy this one, and we need to change our service because currently it is also exposing the other world. Just front end. Yes. kubectl apply -f front end unchanged. Okay, kubectl, because currently it is load balancer, we need to delete this because we can't change load balancer to cluster IP. We can change cluster IP to load balancer, but vice versa is not possible. We will get some error. kubectl delete service, then followed by service name. ls. Now kubectl apply -f, then our front end, it will create service. Here service is created. Now if you check, yes, service will be our cluster IP. Here this front end is cluster IP. Now we need to create gateway. kubectl apply -f gateway.yaml. So now it is also getting created. Now what we need to do now, just go to route 53. Where is this? Yeah. So if you go and check to our load balancer, we will have 2-3 load balancer, but for ingress we have one specific one. So in tags also you can see this is istio, this is for istio-ingress, and for this you can see this is for WordPress, and this is for grafana, and this is for kiali. But now we need to focus on this istio namespaces. So just copy this DNS and go to route 53, because currently also if you go on this, you will get some error 404 page. This means page not found error. So now if we go to route 53, just we need to add this route. EKS alias. Just to save record, it will redirect to this one. Now if I do EKS dot yeah, now here you can see our app is working with this particular namespaces. And for this, like here, if you want to add some SSL certificate, just add into this load balancer. So where is our load balancer? It will be redirected to this one. 443 is also there. We are using a ELB, right? We need to add this in server end. Wait, let's check. TCP 443. It will be TCP and instance port will be same. SSL. Okay, we need to add first, then we are able to do. Oh, let's remove this. So now our this EKS is working fine. Now also we need to do route some this thing with our WordPress site. So just do this thing, edit this test with WordPress, and it will also redirect to our which one, ABCC, this one, save route. So currently if we do WordPress dot hypercloud.in, it will not work. It will give us 404 error because page not found. Now just we need to come on our configuration file here. What we need to do here, if we do kubectl get svc. So here what we have one load balancer. Just delete this one. Wait, where is this file? WordPress service. Type load balancer, change it to cluster IP. because we can't do like I told you previously also, we can't change load balancer to cluster IP. So just use kubectl delete service, then this name. Now service is created. kubectl get svc. Here we have cluster IP for this WordPress stateful set. Now we need to come on this again, gateway. Where is this one? So now we need to create one more virtual service for this particular service. Just copy and paste. This will be for our WordPress app, and host will be our WordPress.hypercloud.in. Gateway will be same, route, host, and our host will be this one, and it will listen on port 80. kubectl apply. Yeah, one site will be configured now. Now if we go let's check this one. ECS demo frontend, okay, for this WordPress SQL. It is listening on port 80, right? Page not found. Let's check host. It is resolving. Okay. It is listening on port 80 front end. It will take little time. Wait. Let's check on istio dashboard. Here we can find error. So for front end, okay, I think it is happening because of stateful set, I guess. Requests are coming. App WordPress, right? Istio config WordPress app YAML. Virtual service app testing server. Okay, service name. Stateful set. This we need to create this again. Because here our service name will be different from previous. Delete. Okay, route is not. Hello. Okay, let's check. I will check this after some time. Let's go further for other deployments. So there will be. Oh, so now what we did, we created one EKS demo app, one WordPress app, Kiali dashboard, Grafana, and we use istio-ingress also. And now we know how we can route our traffic to each services. And apart from this, we need to install EFK. EFK will be Elasticsearch, Fluentd, and Kibana for logging stuff. Now what is time? Oh, so currently 10 o'clock. So we will continue this tomorrow. So anyone have any question? Hello. Dhani, Aditya, Deepak, Paresh, Siva, Vikram.
Hey, hi, Ashish.
Hi.
Vikram here. Can you hear me?
Yeah, I can hear you.
So I just need in the high level how this ingress control will works.
Okay,
The
so
high level.
high level overview. Okay, so let me draw something. So yeah, this one. So suppose what we have here, suppose this is your so suppose this is your Kubernetes cluster, right? And what you need to do, just suppose, and this will be your endpoint. So suppose this is your ingress controller, like yes. Suppose this is your ingress gateway, right? And based on this, your public exposed traffic will come here. Suppose because if you don't specify anything uh, on that case, no traffic will be come to your Kubernetes cluster, because in Kubernetes also you can see this is totally isolated. You can't access public from your any each of your cluster pods. So this will be responsible for incoming gateway for your all requests. After that, you will have you will get some this thing here. You will have one gateway. This will be your virtual gateway. And apart from this, you will also have one virtual service. Virtual virtual service. So this will be like simple as your gateway, but you can use multiple gateway for each thing. Now what here it will do, and suppose here also you have multiple services like demo app and WordPress site, Grafana, and so on. So this flow like will be like, this will be your load balancer, this is your internal gateway, this is your internal service. Based on this, it will route to particular traffic. Like one more thing, like suppose if we can see our current configuration here, we have one gateway, and we have some virtual service. And in virtual service, what I am doing, we have one host. And why it is not happening? Because I got answer. Because in gateway, what we are doing, we are allowing only this particular subdomain. So what our ingress is doing, it will only allow this thing, but for this particular site it is not allowing. So we need to mention here also this. Now it will able to use. kubectl apply gateway.yaml. Now after some time it will work. Like for example, suppose if I do copy curl, yeah, now we are able to see this one. So if you want, you can just type on your browser wordpress.hypercloud.in, our service will work. But previously it was not working because I forget to allow this on our gateway. So this particular gateway, yeah. So this is your load balancer. This is your internal gateway. Based on this, your traffic will be allowed into your cluster. And this is your virtual service. So you can have multiple virtual service. So suppose currently this is for our WordPress site, and you can also define for other services. And this will check your path and your host, and it will redirect your traffic. And also istio will provide lots of things, like it will, by using this you can also see all the traffic and logs, like for from this spot to this spot, how it will reach and how much time it will take to reach from this spot to this spot. Got it? Or any other question is left?
Yeah, so thanks, Ashish. So can you relate the Kubernetes components with this each service?
What?
Can you relate any of the services
With
with like Kubernetes components with this?
from this?
Yeah.
Okay, so I told you in previous also, like Istio is using CRDs, like custom resource definition. So in Kubernetes, like you will have pods and deployments and other thing, right?
Yes.
So in here also, ingress is a different type of service, like kind of service. Like in service also, you can think as a cluster IP, node port, load balancer, and this ingress also, it comes under this thing.
Okay.
Virtual
This is
service.
separate component altogether.
Yeah, separate component. And like suppose if you wait, let me share my screen. So suppose if I do here kubectl crds, okay, get crds. Okay, so currently this will be this created by some gateway. Like see here, you can see gateways.networking.istio.io. This is its own crd.
Okay.
And you can see on here API will see here it is different thing, right? So currently you will see v1 or v1 slash extension v1 or v1 slash apps, this type of things you can see in API version. And this is different thing. This is like custom CRDs.
So what is that CRDs terms called?
CRD, what?
What is that like the
full form?
definition of full form.
Custom resource definition.
Okay. So in the Kubernetes service, so automatically these services will get generated in the backend, right?
Yeah, right.
Okay. So if you want to do any custom CRDs, then what is the thing I have to do?
You need to create your own one. Like suppose what now how these things are working. Like
sorry guys, like don't please hesitate.
Like suppose this what we can say, istio is like nothing but it also like what we can say, it's kind of a umbrella in like suppose if you ever wait, let me show you some diagram so you will have better understanding on istio components. Where we have istio, right? Wait. You can see these notes, istio architecture.
Yes, I can see.
Yeah. So here, how things are working, same thing on same thing like Kubernetes work. You will have one master control, you will have control plane, and you will have data plane. Data plane is like worker nodes. Control plane will be that manage all the things, right? So in control plane also you will have lots of component like Citadel, Galley, Pilot, Mixer, and in this thing you will have proxy, and this proxy is nothing but a envoy proxy. You ever heard about envoy proxy? So this istio, this developer of this istio one, they took this as a service because it is this envoy proxy is also open source, so they took it in istio mesh, and by using this they are able to communicate. Like see here you can see this is using proxy. So this is your front end. In suppose this is your pod, right? And in pod your service is working, right? And what istio will do, it will add this side container into your pod. So if this service want to access this one, so how it will not directly communicate with this, it will go through with this proxy. So by using this, like your connection will be secure, and also you will have lots of things like you can also see all the traffic visualization and how much time it will taking from going to here to there.
Yeah, got it.
And also some problem is also you will get by using this type of managed service. Like suppose if you want to upgrade istio, it is very painful. And if you want to, like suppose what happened if your TLS certificate went as expire, so these things you need to take care of it.
So that again we need to save this complete server's configuration,
right. This is also one diagram. So galley here, this all component will be for different things.
So the services which they are maintaining in the pods, so those are all the main hardware, right?
Right.
Okay, thank you.
Any other doubts?
No, thank you, Ashish.